Welcome to our lecture about Internet, weaknesses and targets. Today we want to speak about the Internet, the World Wide Web, and give a survey about the technologies behind. This is the lecture series content table. We are in the chapter speaking in the introductory chapter. Last time we spoke about, gave an overview about Internet security, and today we want to give an overview about Internet technology and web systems. Then later we will speak about risk analysis, and then the main part, the main topic of the lecture is this Internet weakness and targets. Then we have a lot of lectures about that. So let's start with the Internet. Everyone knows Internet, everyone knows the World Wide Web. If you look then today, about 1 billion hosts all over the world are connected to the Internet. They are able to exchange information by the Internet. So all places in the world are connected. Everyone knows how Internet is changing our society. And of course, the more important information exchanged via the Internet, the more tasks people using the Internet, e-business, buying books, buying other things, changing information, the more security becomes important. So security is more and more a key factor for using Internet and World Wide Web. But to understand the security issues, to discuss problems, weaknesses of the Internet protocols, of the different applications, before one can do this, one needs to understand network technology. One needs to understand how Internet is working. One needs to understand the web technologies. And exactly that's the reason that we have to start our lecture series about Internet security by having a closer look to the Internet and to the World Wide Web, to understand the various security problems occurring around the use of Internet and World Wide Web, to understand how attackers, how hackers try to attack a system, try to get access, for example, to secret information or to misuse other identities in the Internet. To understand such different threat scenarios and attack methods, it is important to understand the Internet technology. And, of course, to develop protection mechanisms against such attacks. It needs an understanding of the Internet protocols, of the Internet technology, of the network technology, and of the mechanisms that are used in the different Internet applications. So let's start to have a closer look to the Internet. You know, Internet is a network of network. It's a network of computer networks. Each of these networks, for example here, our HPI network or the network at home, they may be connected by means of Internet technology. In this sense, the Internet is a virtual network. Let's have a closer look to computer networks. Computer networks consists of different components. Of course, it consists of computers. These are the computers that are exchanging information, that communicating via the network. And if we look to the way how these computers interact to each other, we can differentiate between two types of computers. There is one type called the server, and the server is providing resources. For example, documents, for example, computational or storage resources. So they are waiting for requests to provide their resources. And the other type of computers or systems in a network are the clients. And the clients, these are the active part. They make active use of the resources offered by the servers. Now you cannot see, you cannot think that in a computer networks, you can exactly say this is a server computer or this is a client computer. This differentiation depends from a concrete communication activity. So a computer can be in the same moment in one communication, the server component, and in the other communication, the client component. This server-client model was designed to help to understand the very complex task of a communication of computer systems. So speaking about computer networks, so on the one side we have the computers as one of the components. The other component are the transmission media. Could be different types. It could be a cable. It could be other physical media. It could be radio waves or light or other things. So a media that connects the different computers so that they are able to exchange signals, the signals that code the messages the computers want to exchange. So, and we have wired transmission media, for example, twisted pair, coaxial cable, optical fiber, and others. And we have wireless transmission media, radio waves, infrared signals, and others. And the third component computer networks is consisting of are the infrastructure components. These infrastructure components are network adapters or network interfaces. By means of these network interfaces, the signals, the bits which encode a message are transformed into physical signals. For example, if a cable is used, then this network adapter transforms bits into electrical signals, the signals that can be transmitted via the transmission media to another computer. So computers, transmission media, and infrastructure components, these are the components of a computer network. So the communication within a computer network needs to be ruled in a very fine, up to a very fine grade of details. And the network systems, the network communication system is it's called network protocols, and these network protocols, they rule all the communication all the tasks that are needed to make communication possible. So if we have a look here to the large amount of network protocols, this map is not necessary to understand in detail, it's only to illustrate that there are many, many details that need to be ruled. Protocol is responsible to do this, to make communication within a computer network possible. So, for example, these network protocols, they have to rule the format of the transmitted messages. Network protocols have to define an address schema to address, for example, a host to address the computer message is sent to. Or the network protocols have to exactly rule each possible step in the communication process and the methods for controlling whether this communication process works correctly. So these network protocols is something like the computational system of a network. If we look to computer networks, then we see that there are very different types of computer networks. We can classify the computer networks, for example, according to their geographical scope, to the types of connection, to the usage of the network. So there are different aspects. To demonstrate only one, I show you a classification of computer networks based on the geographical scope, based on the scale of the network. So we can start with very minimal here, 0.1 meter. If we look to computer networks that are placed on a ship. So, for example, in a multiprocessor system, that is a computer network. If we look to a little bit larger scale, for example, a grade of 1 meter, then we can consider multiprocessor clusters as computer networks. If we upgrade scale to look around the room, 10 meters, then so-called personal area networks. Personal area networks are in place. For example, in your home, the connection between the computer and the printer. This is a computer network. If we look to a larger scale, say in a range of 1 kilometer, and if we not restrict ourselves to a room of a building, if we look to the complete building, to a campus, then we have local area networks, so-called LANs. If we upgrade to 10 kilometers, then we can consider metropolitan area networks. If we go to the scale of 100 to 1,000 kilometer distance, and computers that communicate over such a distance, then we can see and can consider wide area networks. And of course, the network connecting the planet, connecting different networks on the planet, then we get the internet. If you see these very different types of computer networks, it is immediately clear that for each of these types, another technology is useful to be applied for performing such communication tasks. So typically, the World Wide Web, the Internet, consists of many local area networks that are placed and that are connected by technologies which are developed in this area of wide area networks. You can classify computer networks also according to the goal that needs to be fulfilled, or other parameters. If we look to computer systems, then we could ask ourselves, are computer systems distributed systems? Of course, they are. But when we speak in computer science about distributed systems, then we have another idea compared when we speak about computer networks. So in common, distributed systems and computer networks have in common that there are many individual separate components that are cooperating together to fulfill certain tasks. The components are distinct, they are physically different, they are logically different, and they cooperate to fulfill a certain goal. So this is a property that is shared as well by distributed systems as well as by computer networks. In both systems, the individual components are spatially distributed and operate autonomously. They operate autonomously, but in cooperation. So this is what both distributed system computer networks have in common. What is the difference between distributed system and computer networks? In distributed systems, each involved component, each of the autonomous components works transparently. Transparently means that the user cannot identify which component of the distributed system does a certain task in the process. So they work transparently, and usually they are controlled, they are managed by a control process. It is not important to know for the user, and often the user cannot see what exactly happens in one of the components. In computer networks, one can see, and it's not transparently, one can see what is performed in each component. So in computer networks, which are controlled by the network operating system. Network operating systems, this was the network protocols, the communication protocols. And this network operating system that coordinates the processing steps of a user request. Coming back to the classification of computer networks, and have a look to classification along other criteria. For example, looking to the usage criteria. So we can recognize function sharing networks. Function sharing networks are networks that making different functions available at different locations by allowing access to specialized servers. For example, to supercomputers or vector computers, they perform a task of graphical computation or simulation, and other components are performed, for example, in storage machines or others. We can recognize load sharing networks. These are networks that guarantee that a certain resources are offered even from different computers, so that even in a situation of special load, the service is provided in a correct way, because if one computer is overloaded, then another computer provides this functionality, so that the user can trust that the resource he needs he gets. We can consider data sharing networks. So here the idea is to provide a better utilization of the storages like the disk, to provide an increased availability or increased safety for the data and the communication. And very important are these high reliability networks. These are systems that guarantee that functionality is provided even when a system failure occur or a machine are crashing. So there are other criteria we can see. For example, we can distinguish between homogeneous and heterogeneous computer networks. Homogeneous networks are networks where all computers have the same shape, the same type. Heterogeneous computer networks are characterized that they connect different computer types together. One can distinguish open versus private computer networks. Open means there is an access for everyone. There is a provider that provides a network. The user has to pay for usage of the network, but he can use this infrastructure. The private computer networks, typically these are restricted to a limited number of people that use. For example, a private computer network is a network of a company that provides all the employees, which allows all the employees to get access, but which cannot be accessed by people not allowed to do this. And then, particularly with respect to security aspects, the virtual private networks are an important type of computer network. This looks like and feels like a private network, but in truth, it is a part of the internet. So here, the privateness comes from the fact that that cryptographic methods are used, so that the people, although they use the open internet in their communication inside the network, they are closed in a sense that only those people can contribute, can take part, can see information, which know the keys for this cryptographic encoded information. So there are more usage criteria possible. I advise you to have a closer look here, for example, in the literature. When we start, I said Internet is a network of networks. In this way, the Internet is a virtual computer network. And what is needed is regulation that these different networks that are run with different technologies can connect it to each other to form one network that looks as a homogeneous network. So physically, the Internet consists of different computer networks that are incompatible to each other. It's very important. So you can have a LAN technology, you can have an Ethernet, you can have an ATM network, you can have different types of networks technologies used inside such a network. The idea of Internet is to interconnect these different types of network so that the user has a feeling that it's a unique, homogeneous network. That's exactly what we want to say with the word virtual computer network. So the homogeneity is an illusion. It's an illusion that the different networks form one large, unique network. And this illusion is created by means of software tools. And these software tools are the already mentioned Internet protocols. The Internet protocols that do the task to interconnect these networks, not only physically, but also in a way that one can transmit data over the boundaries of single computer networks to other computer networks. So these Internet protocols have to rule how to identify the participants of this internet, the interconnection of the networks. Because inside the network, each computer is exactly specified. This is done by this network technology. But if you interconnect different such networks, a schema is needed that allows to identify from one network a participant of a completely different network. These Internet protocols have to clarify who is the target of a message. They have to identify how this message has to be transmitted. Inside one network, all things are clear. But how to transmit messages over the boundary of one network into another, perhaps into the next one. So the route, the path over these different networks needs to be ruled, and the Internet protocols need to provide messages, need to provide mechanisms for finding a path, finding a good path across all the interconnected networks to bring one message from the sender to the receiver. Or Internet protocols have to take care that the message arrive in a good shape, that there are no failures in the interconnection of the networks, no failures that damage the message or bring errors. So this is only a few of the huge amount of tasks that need to be solved by the Internet protocols. This is a very simple image of the structure of an Internet. So here we have the regional networks. So we have, for example, an HPI network. We have in another department of the University Potsdam network. We have a network in a company here in Babelsberg, for example, in the studios. And all these networks are interconnected in such a regional network. And now if we want, for example, from HPI send a message to our friends in Stanford University, then we have to use internet technologies that connect the regional network here in our region with a regional network in California, and there are backbone networks that help to interconnect the various regional networks. So this is very simple because it is hundreds of thousands of networks that are interconnected by the internet. Another interesting fact is how it's possible to access the internet. So here we have the internet with the ISP, with the internet service provider. The internet service provider are those that provide customers, that provide people, that provide companies access to the internet. And this access to the internet are provided, for example, via such gateways, also routers. And here is an example that an Ethernet local area network, for example, local area network of the HPI, is connected via the Deutsche Forschungsnetz. This is the internet service provider of universities, is connected via the services of the Forschungsnetz with other networks connected to the internet. We can have such wireless LANs. In this wireless LANs, one needs access points. Access points so that the computers in the area of such, in the range of such an access point can connect via radio waves with the access point, and the access point is connected via a gateway with the internet. We can access the internet via our cellular phones, for example, by GSM technology or UMTS, so the technology so that you can use your smartphone also, for example, to check internet sites, others. For long distance, it is possible to use satellite technology to connect networks with the internet. Of course, the telephone network. We already spoke about the mobile telephone technology, but also the cable-based telephone technology can provide access and can be used as connection as a connection mean to the internet. And last but not least, the cable technology. So you see, we have various types of technologies that make it possible to connect the own computer, the own mobile device, the local network with the internet. Here's only a short picture that shows how internet changed our life. In this short time of existence, so internet started to be developed in the 60s, late century, but it became popular in the 90s. So it's only a couple of decades old, and already now all parts of life are changed. So, for example, here we use internet technology for university, for learning, for teaching. We can use internet for e-business, buying books, accessing videos, of course, sending messages, exchanging information, getting resources, for example, to store our photos and other things. So you all know that by means of the internet, in a historical, very short time, many things are changed, no new services are provided, and many things we have clearly to say that many things we do not completely understood how to manage these possibilities provided by digital world. So now let's have a little bit the closer look to the technology behind the internet and the internet protocols. Typically in a network, the technology that's used, for example, in an Ethernet or in wireless LAN, this is a proprietary technology. That means a company has designed these technologies. Company is responsible so that this technology is so good that customers want to have this, that customers are willing to pay for these networks to solve their task of installing a network. So this is the situation in the single networks. But if we look to the internet, then it's different. The internet is not owned by industry. So they are not secured by patents and trade secrets. The internet, the worldwide internet, is an open system. It's an open system that means all the regulations, all the specifications, all the protocols are publicly available. They are available in form of standards. The standards in the internet are called RFCs, request for comments. So any company, any student, any researcher can understand these protocols, can understand the standards, and can create on top of the standards his own technique, his own system, his own service. And this is perhaps one of the secrets why internet become in such a historical short time so popular. All the internet documentations, all getting access to the standards, all is publicly available. There is an internet society that helps that everyone can have access to the technology descriptions of the internet technologies. So this exponential development the internet has received during the last years, the last decades, this was done, or this was pushed by this openness. So a lot of other software systems follow this example. So the open source is something similar, an approach that everyone is invited to take part in the development, to contribute to the development, because everyone has complete access to all the technical bases. Now, let's have a look how this communication can be organized. And if one tries to understand, or if one tries to design a system that allows computers to exchange messages via different network technologies, over different technologies, then one sees it's a very, very complex task. A very complex task, and an old approach to complex tasks is to separate it into single different tasks. And exactly this is done in the case of communication. The internet protocols are conceptually organized in so-called layers. And these layers are hierarchical ordered in a sense that all the protocols solving a task of one layer needs only input from the protocols one layer above or one layer below. This approach to understand and describe and to model communication process by means of layering models. There are two famous such layering models. The one which was theoretical, developed when when the network technology was increasing, is a so-called OSI reference model, and the other model is taken from the practical development of the internet technology. It is the model that's implemented by the TCP/IP protocol, and TCP/IP are two important protocols in the internet protocol suite. So sometimes instead of speaking from the internet protocols, one is speaking from TCP/IP models, TCP protocols. Here's a short view. We do not want to go into much details. You see the OSI reference model starts with a physical layer, then there's a data link layer, a network layer, transport layer, session, presentation, application layer. And the TCP/IP protocol is more simple, has only 4 or 5, it depends from the different viewpoints. The network interface, the internet layer, transport layer, application layer. And this is how, along this model, this exactly describes how TCP/IP protocol suite is designed. So I already mentioned TCP/IP protocol stack because there is a stack of different protocols in the different layer, starts or ends, how you look. So that's in my picture it was on the bottom. Start with a network layer, and the network layer is responsible for transporting the IP datagrams. This is the IP, the internet datagrams. This is the package. Each message is separated into such IP datagrams, and this IP datagram is transported on a concrete network, on a specific network. So this is the network interface layer, is a connection of this internet that is interconnecting different networks, and is exactly the protocol or the interface to the specific networks. On top of the network interface layer, we have the internet layer, and the internet layer, it handles the communication. The communication from machine to machine. The machines may belong to different networks. So the task of the internet layer is to provide an addressing scheme and to provide a format so that the messages from one machine, from one network, can be sent to another machine, possibly in another network, and these are so-called IP datagrams. So the messages are packed into such IP datagrams, and the IP datagrams are addressed according to the internet protocol scheme, and they are routed over the different networks from the sender to the receiver. On top of the internet layer, there is a transport layer, and the transport layer provides a universal transport service for an end-to-end communication between applications, not between the computers. On the computers running applications, maybe different applications, and TCP provides a transport service from one application of one computer to another application running on another computer. To mention important examples, so on the internet layer, I forgot to mention the IP protocol. It's the protocol that gives the internet the name, or it's named after the internet. Here in the transport layer, the most important protocols are TCP and UDP protocol. And then we have the application layer, and the application layer that provides interfaces that the application running on a computer can use the internet for communication with an application that's running on another computer. So in that sense, it extends the network operation system so that applications can communicate via the internet. And important protocols here are the protocol that's used in the World Wide Web, HTTP, the protocol that's used for email communication, SMTP, the protocol that's used for file transfer, the file transfer. Now, and we will do this in great detail in the lecture, when we look to this many protocols, these are only a few examples I mentioned here, then the vulnerability and the weakness of the internet communication often is based on vulnerabilities and weaknesses of these protocols that are used and of the interaction of these protocols. So we have to understand this in detail to be able to design prevention methods to prevent attacks against these internet communication. So this is done in detail in other lectures. Let's have a closer look to the different layers and the protocols that are placed on this layer. Let's go back to the network interface layer. So the term network interface, that should give the idea that exactly this layer is very close to the physical network. And the physical network with a network technology, with a proprietary network technology. So internet, of course, at the end can only transport messages via these physical networks, using these incompatible technologies on the physical networks. And the interaction between this internet protocols and the networks, physical networks, this is organized on this network layer. Here, the core protocols are specified by the Internet Engineering Task Force, IETF, not only on this layer, but also on the other layer. And the core protocol to be placed into this layer are, for example, the address resolution protocol and the reverse address resolution protocol. It helps to translate the IP addresses, the internet addresses, into the network addresses and vice versa. Another very important protocol on this network layer is the Neighbor Discovery Protocol, NDP, for delivery similar functionalities as RIP in the new IPv6 networks. We have the Layer 2 Tunneling protocol that's used as a tunneling protocol for virtual private networks. We have the Media Access Control Protocol on this network layer for Ethernet, DSL, ISDN, FDDI, so the different networks technologies. And there are much more protocols, but these protocols help to that this virtual network can physically be used to transport messages by using the different physical networks involved. Let's have a closer look to the internet layer. So the internet layer, in a certain sense, this is the first layer above of these different networks. So it consists of a group of internet working methods, protocols, and specifications, which are used to transmit data packets from one host, the originating host, to the destination host. The core protocols in the internet layer are most important and most prominent, the internet protocol. For that reason, because it's so important, the whole stack of internet protocols often is called TCP/IP protocol. This IP protocol exists in two versions. Today, mostly the IP protocol version 4 is used, but there are no free addresses available, so we have to use in future the IPv6 protocol, and we live in a time where we have to migrate from the IPv4 protocol to IPv6. Then we have the ICMP protocol, also in two versions for the IPv4 protocol and for the IPv6 protocol. So it's the Internet Control Message Protocol. This is used for sending messages about errors and to provide diagnostic functions. Then we have the Internet Group Management Protocol, the IGMP, which allows that IPv4 hosts and adjacent multicast routers to establish multicast groups. We have the Internet Protocol Security, IPsec. This is for securing the IP protocol by means of cryptographic methods to provide means for authentication and encryption. Then, looking to IPv4, its range is not enough for all new devices. So in the starting phase of the internet, one was thinking if each person has one computer and one provides so many addresses that the one computer can be connected to the internet, it was a reason to work with relatively short, with 32-bit long IPv4 addresses. But meanwhile, you know, we want to have many addresses. We have many devices, our smartphone, our laptop, our computer, our radios, GPS, cars, TVs, and all these devices want to be used for accessing internet services. So the IPv4 addresses are not enough for that, and indeed it was in 2011 that the last free IPv4 address was given to an internet service provider. For that reason, IPv6 was developed for a long time and was waiting to be used. And now, this is also called IP Next Generation Protocol for future internet, and this protocol allows a lot of devices, provides a huge amount of internet addresses because it allows to use 128-bit for characterizing internet address. So here is a short table to show the main characteristics in comparison from IPv4 and IPv6. So the specifications from IPv4 date back to 81, and specification of IPv6 date back to 98. Address size, I already mentioned, is IPv4 32 bits, and IPv6 provides 128-bit addresses. So the number of computers that may be connected to the internet by means of a known IP address here in the IPv4 world is about 4 billion. And here in the IPv6 world, I cannot even mention the name trillion of trillion addresses. So each cent corner on the earth can get, in principle, an address, an IPv6 address. The address formats are different. So here the address of IPv4 addresses, you know, these are four groups of digital numbers. In case of IPv6, to hold the address relatively small, an hexadecimal notation is used by means, and it's distinguished by IPv4 by using such 2 points. And then we have prefix notations in different ways for the two protocols. Let's go one layer up to the transport layer. The transport layer offers services such as connection-oriented data stream support. The transport protocols allow reliable communication. They have mechanisms for flow control, for congestion avoidance, for multiplexing. So to guarantee that in the IP level only best effort communication is organized. But here on the transport layer, there are guarantees given, at least if one is using and working with the TCP protocol, that certain services are, that communication works correctly. Protocols, important protocols on this layer are the Transmission Control Protocol, TCP. Beside of IP, the TCP protocol is considered the second most important protocol in the protocol stack of the internet protocols. For that reason, we speak about TCP IP protocol stack. And this is for stateful connections. Beside of that, a much simpler transport protocol is available for short messages without any guarantees on reliability and others. This is a UDP protocol. We have the datagram congestion control protocol on the transport layer. We have the stream control protocol for the multimedia use, for the transport of multimedia information via the internet. We have the resource reservation protocol that helps to organize resources for such multimedia communication, and many, many others. So, and then the topmost layer in the TCP/IP protocol stack is the application layer. Here, the protocols in the application. So the application itself does not belong to the protocol stack. In the protocol stack, on the application level, there is support provided that an application can use internet to communicate with the same application on another computer. So in this sense, a semantic conversion is provided between the associated application process that run on different computers. The application layer focuses more on the network services, more on application programming, interfaces, the APIs, utilities, and operating system environment. And popular protocols from the application layer, you see here, there are a large number, is BGP, DHCP, DNS, domain name service, file transfer service, the protocol for using for communicating web pages, HTTP, IMAC for getting access to email system, LDAP, NNTP, NTP, POP, RPC. So here, for example, the SMTP protocol that makes possible to send email, then the different protocols providing access. So we cannot go in detail, and this lecture is only one survey. So when we later discuss weaknesses of different protocols, and I expect that you have an understanding and have access to literature to see more details about this special protocol. A few words about internet service and applications. The internet applications that use the service provided in the application layer. So there are applications, for example, email application on two computers, and the owner of these computers want to send to each other emails. So they work with the application running on their computer, and this application has access via, for example, in this case, the SMTP protocol to the stack, to the TCP/IP stack, so that internet can be used for exchanging this email. We already discussed that the typical communication model that's used for internet application is the client-server principle. There is a client. Often people speak from a computer, but it is a process, a client process, that actively requests information or requests services or requests other types of resources from a system that's called server. And the server system is passively waiting for such client requests, and then if the client is authorized to use the offered, to make use of the offered resources, then the server responds with the expected information or the expected service or the response. So the client-server interaction, the model of client-server interaction, make it easier to understand the communication process and to design and support this communication process by means of the protocols. So client and server interact by exchanging messages over the network. The internet, of course, provides a lot of important services. I can mention only a few. For example, the possibility to transfer large files by means of the FTP service provides a possibility to use, beside of the numerical IP address, so-called domain names naming services. Internet provide directory services. An example, for example, is LDAP. Internet provides message exchange services. For example, the email service. The email service that's based on SMTP. And if I want to use the email service, the SMTP protocol only can transmit text messages. So if I want to attach an image or a video to my email, the MIME standard is needed to transform this into a text message, and there exist systems like BGP to secure the communication. Then another type of service that's provided by the Internet is the Internet chat. So, for example, by the IRC protocol, and then the most important service provided by the Internet is the World Wide Web. So, for that reason, often people use World Wide Web as a synonym for Internet. And the protocol that's based on World Wide Web is the HTTP protocol. I come later to this in more detail. So here is a zoo of many, many applications that make Internet so famous and usable. I mentioned the most important Internet service is the World Wide Web service based on HTTP. So often, instead of Internet, people speaking from the web. World Wide Web, www, W3, or simply web is the most important Internet service. It is an interactive distributed hypermedia system. What means hypermedia? On one side, media means that not only text messages can be, not only text documents can be accessed via the web, but also multimedia documents, videos, images, and others. And this is the media, that multimedia, that many media can be accessed via the web. And the hyper, the notion hyper comes from this mechanism of hyperlinks. So that the resources in the World Wide Web are interconnected by so-called links, so that access from one document that has a link to another document makes it very easy to access the other document. If we look to the history of the World Wide Web, we see that it was very important for the development of the Internet that the web client is a web application, it's a client-server application. The web client is the browser, and the Internet starts to become so popular when the first browser appears with an intuitive graphical user interface. So that's easy to use only mouse clicks instead of writing some names into some fields, simply by using mouse click to which make it possible to access data. Famous clients are Firefox, Chrome, Internet Explorer, and they are something like a window into this World Wide Web. The web was introduced 1990 in Europe. So it was in the CERN, the European Organization of Nuclear Research. It was introduced by Robert Calleux and Tim Berners-Lee as a service for Internet-based exchange for administration documents and experimental results at the CERN. CERN is a research organization of the European Union. So the researchers come for a time to this place, do their research in very expensive machines, and then later they go back to their universities, to their national research institutions. And the question was how data can easily, for the nuclear research, the large amount of test results and experimental results how to provide a mean for an easy access to this data. And this was when the World Wide Web technique was introduced. The web has 3 columns. The first 3 basic standards. The first is the language, the hypertext markup language, HTML, which can be used to design web documents. HTML specifies the format and assembly of hypertext documents, so-called HTML documents, and this HTML documents, this is the main resource of the web. Then the second column, the second basic standard, are the URL, the Uniform Resource Locator. This is an addressing scheme which allows to identify the location of the data that may be accessed via the web. So it provides an addressing scheme for each that allows to give each resources in the World Wide Web a unique address. And the third column, the third basic standard, that is HTTP, the protocol, the hypertext transfer protocol, which allows and which organizes the communication and the transmission of HTML documents via the internet. Meanwhile, the web consists of hundreds of millions of hypermedia documents, which are described in the HTML language. So hypermedia document, I mentioned this already, consists of different components. It consists of the hypertext. Hyper shows that in this text there are contained hyperlinks to other parts of this document or to other documents that even maybe reside on other computers. It consists of hypermedia. So now it's not only text, the document can also offer audio information, graphic, video, or other medias, but also here together with this hyperlinks. And the hypermedia document that can be the hyperlinks make it very easy to access hypermedia documents easily by a simple mouse click. And in this way, all the documents of the World Wide Web are interconnected to form a network of information. A network of information, and the single pieces, the single documents, are interconnected by each other by means of these hyperlinks. So in this way, hyperlinks are the main characteristic of this hypermedia documents, and you see the original way, for example, we know from books, there we have a sequential way to put one information after the other. By means of this hyperlink, we can open this sequential way to a network that helps to provide different interconnections between the different web documents. To access hypermedia documents on the web, a unique name is needed. A unique name is needed for each document. I already mentioned the naming scheme that's used is URL, Uniform Resource Locator. And this Uniform Resource Locator that identifies a document by means of the internet name of the computer where the resource is located, and by means of the directory path on that computer where the resource is located. So a Uniform Resource Locator says which computer in the internet and in which place on this computer a certain web document may be found and may be requested. And then we have the HTTP protocol that's used in the following way. First, it's a very simple protocol. This comes from the time it was developed 1919, and bandwidth was small, internet not so stable. So the HTTP protocol is a stateless protocol, a very simple protocol, but it allows to access to request and respond with the web documents over the internet. So the scheme that's implemented in this very simple protocol is request. So a client is requesting a data, and then the server looks whether the data is available, whether it's allowed to send the data to the client, and then there is a response. So the web page or a message arrow is sent back to the requesting client. And then a new cycle, a new request-response cycle started. So each data exchange between sender and receiver is completely independent from previous data exchange with that computer or with other computers in this way. When we speak about the World Wide Web, often you see the terms Web 2.0 or Web 3.0. Let's have a look what is meant when people speak from Web 2.0. What they mean is not a special technology. What people mean and want to cite when they speak about Web 2.0 is the new behaviors, the new usage of the web. And here in this picture you see Web 2.0, these are blocks, this is mobility, this is data-driven, that is web standards, this is Ajax, that is wikis, that's folksonomy. So the Web 2.0 is commonly associated with web applications that facilitate interactive information, sharing information, interoperability, user-centered design and collaboration in the web. In the beginning, there were some people that put information on the web, and the others are allowed to request and see this information. With Web 2.0, every internet user can become an internet author, can can contribute with his information, with his materials to the World Wide Web. So in this way, Web 2.0 does not refer to a very special technical way or to a special technique specification. It refers to this new collaborative behavior. So examples of Web 2.0 include the social networks. Social networks include blogs, include video sharing sites, hosted services, web services, massive open online courses, and others. So this is meant when people speak of Web 2.0. And of course, there are technologies involved, web technologies involved like XML, RSS, SOAP, and the asynchronous JavaScript and XML, the Ajax and Adobe Flash. These are techniques, but these are techniques that exist independent from this Web 2.0 approach. Now we have to consider how the web server and the web clients are working. I restate that the web is based on the client-server paradigm. This is the basic architectural principle. So the user is requesting a document from a web server by means its client and it's his or her client, that is a browser. The browser is the web client. So the web documents are identified by the URLs, and both the browser and the server communicate with each other by means of the HTTP protocol for requesting a page and getting response. So the server accesses the specific documents from its local file system, and you remember in the URL, the second part identifies this the place of the document in the local file system, and then the server requests this data requested by the client and send it back to the client. And then the browser receives this web document, and it has to interpret the document, and it has to present it to the user. So in this way, the browser is a quite complex architecture, a quite complex software program. It's much more complex than the web server. Beside of the communication with the web server, with the web servers, the browser needs the ability to interpret and to display the requested document in a correct way. And to be able to do this, it needs to be able to open a connection to the web server. The web server that is characterized by the link that is in a document requested by a mouse click by the user. Then the browser receives the answer of the web server, typically the document, and then it has to interpret, render, and display this document in the correct way. And then the user is able to do some actions, for example, to go to a certain position in the document and to perform a mouse click. So the browser needs to be able to exactly find out what the user wants with this action, and then the browser needs to react in the correct way. So the browser complex system needs different components to be able to perform all these tasks. So the web browser consists of various clients, of an interpreter, of one controller. So controller, this is the brain of the browser. The controller supervises all the browser functions and interprets mouse clicks of the user. The interpreter, particularly the HTML interpreter, is needed to interpret HTML documents, which form the vast majority of the web content. But today, the web browsers are typically integrative systems. So web browser allow also to access other internet services. So to this end, a web browser typically also contain other clients, for example, mail client or FTP client or others. To increase the efficiency of the communication, of the interaction between browser and server, in addition, the browser have caches for storing pages that recently were requested by the user. Let's finish this survey with have a look to the history of the Internet and the World Wide Web, to give only very few dates to show how, in which short time, this new technology has changed our world. So from the 60s, last century, there came the idea of this packet switching, so that the message is fragmented into different pieces, and each piece of this message is sent separately and independent over the internet, and then the receiver puts these different fragments together to reconstruct the message. 1967, the ARPANET, that is grandmom from the internet, the ARPANET project was started, and the project was started, and then in 1969, the ARPANET was started. And it was started with four computers, 3 of them in California, 1 in Denver. And like often in computer science, the start did not work well, but it was a big public event. And then a development was started with get more and more dynamic. So 1907, there was a radio network, the Aloha net, that connected the 4 Hawaii islands to each other. Then 1971, over this infrastructure. The first email was sent, and then a few years later, the ARPANET increased, starting with 4 nodes. Now there were 35 nodes, and in that station, Win Cerf and Robert Kahn developed the TCP protocol. The TCP protocol, and later the ARPANET was changed to use IP TCP protocol, and this was the birth of the Internet. So you can say 1983, this was our Internet, how we know it today, dates back to 1983. So it's 30 years. It's 30 years, so it's not so old. And then the US government helped that universities are connected to each other by means of a high-speed network. So it is NSF-net, the National Science Foundation network. So for universities, they were interconnected by this network, and all the students and researchers there start to use this technology and to develop more services. Interestingly, with increasing of the usage of the Internet, also the attacks against the Internet were increasing. So 1988, the first Internet worm disrupts 10% of the whole Internet in that time. So in that time, the Internet consists of about 60,000 systems. So 6,000 systems were attacked by this worm and were not able to work correctly. 1 year later, the year of German unification, Internet connects 150,000 hosts. So now the worldwide distribution start. And then 90, I already mentioned this, the web service was developed by Robert Caillieu and Tim Berners-Lee. Then this web technology in the beginning was very difficult to use. You have to give alphanumeric signs to accesses when you use a browser. And then 93, the first browser came with a graphical user interface. This was the Mosaic browser, was developed at a university, and later on they formed a startup and used this technology, and everyone knows this as Netscape. They offered this browser, and they continued to develop this browser under the name Netscape browser. So it's the first browser with a graphical user face, and then the web was exploding. The World Wide Web Consortium was funded. The reason was to provide a board that rules the development and give rules and standards for the continuing development of the World Wide Web. In the beginning, Microsoft, which was the most popular provider of operating system, in the beginning they underestimated the development of the web. And then they understood that this is the future, and then they came with Windows 95. They integrated a web browser. So this was the Internet Explorer. So there was at that time a browser war between the Netscape and Microsoft, because everyone wants the people to use his own browser. So I cannot go into detail. Then there was a phase that this huge explosive development was overestimated in its business, in the business context. So many start-up companies started, internet companies started, so-called .com companies started, and within a short time, such internet company was evaluated higher, with a higher amount on the stock market than the real and big and large and global companies. And this bubble becomes larger and larger, and then it breaks. And then there was a phase of the development we know it now. I mentioned Web 2.0. Perhaps I also introduce the notion Web 3.0. And 3.0 means semantic web, service web, and social web. And these are three important developments that also continue to be important. They provide a different way how internet is used. New services came, Google, YouTube, Twitter, Facebook, LinkedIn, and many others that give the internet the face we know it now. I mentioned at the end one date, 2011, and this was a date where from the Internet Authority that controls the use of the internet addresses, the IPv4 addresses, this board gave the last unused addresses to service providers. So this was a signal that now the migration from IPv4 to IPv6 needs to be performed. So who is who in internet? This is a very funny thing. There is no central control. There is no government for the internet that supervises and administrates what's happening. So internet is a collaborative approach. Many people contribute. And of course, it's important to coordinate this work. And this is done by some international organizations that work for the standardization, that help to interchange information and rule the development of the internet. First, in this context, among this international organization, I have to mention the Internet Architectural Board, the IAB, which directs the further development of the internet. The IAB has this RFC editor, request for comments. You remember this was the name of the internet standards. So the IAB is responsible that all the standards are public. And this IAB also creates for solving certain tasks, so-called Internet Task Force. If there is a problem, such an Internet Task Force is established and work to solve these problems. Among this Internet Task Force, there are two particularly important. That is, on one side, the Internet Research Task Force, the IRTF. This is for research about future development of internet and internet technologies. And this is even more important. This is the IATF, the Internet Engineering Task Force, which coordinates the research and development work of various research groups. I have to mention the IANA, the Internet Assigned Number Authority. This was an organization which was originally responsible for managing organization allocation of the internet addresses. Meanwhile, this is done by the ICANN, the Internet Corporation for Assigned Names and Numbers. Today, this organization is ruling and organizing the work with IP addresses. Then, over all these organizations, there was the Internet Society, ISOC, founded in 1992, which supervise and organize all the work of this organization. So one can become a member of ISOC. So it's a very international society that feels responsible for the development of the internet. The ISOC has more than 6,000 members from 170 countries and more than 150 national and regional chapters. The IAB, the Internet Architecture Board, has become a part of this Internet Society. So in this way, this is the way how the development of the internet is organized, is supervised, and controlled. Last remarks concerning the internet standards. I mentioned that the openness of this internet standards was one of the secrets of the success of the internet development, of this dynamical development. So the standardization in the internet is a cooperative process of all the mentioned organizations. The TCP/IP technology is open, it's not proprietary, like in case of the network technologies. Everyone can learn it, everyone can get insight, everyone can implement using it. All the internet standards, the RFCs, are published online and are freely accessible. Nothing can become a standard without a practical implementation. So there is a process making a proposal, and then if people think it's an interesting proposal, they can start to implement these ideas mentioned in the standard. It needs two independent implementation for continue to considering this specification. And this is a very interesting and well-working process. The requests for comments, I already mentioned this. These are the standards. They are published by the Internet Engineering Steering Group, which is the chair of the Internet Engineering Task Force, and there are area directors. And they guarantee that the standards are published, that they are available, and that the standardization process is organized. So the starting point for such a standardization is an internal draft. Internal draft is considered by the by ESG, and then it is published as a RFC proposed standard. When it is published, changed or unchanged, as an RFC draft standard, then one has to wait at least 6 months for discussion this standard. So it is public and the whole internet community can discuss about it, can make remarks, can propose changes. And in that time also it's expected that there are two independent implementations that prove and make it valuable, that prove the idea is useful, the idea works well, idea is performant, and evaluations are possible. And then such a draft standard can become, after this process, an internet official protocol standard. Final remark, as many